Oh man, the gears broke. Hi folks. As many of you who own one of these mini mills knows, the plastic gears that they come with will eventually break, sooner or later. That happened to me. And not knowing any better at the time, I just replaced them with more plastic gears. But I have since learned better, and I have ordered a full set of steel gears from littlemachineshop.com. I'm going to install those now before the plastic gears break again. Now, disassembly of the milling head is rather straightforward up to a certain point, and I've already done that up to that point, which is when you have to push the spindle out through the bearings to get them free from the gears that are inside the housing and are keyed to the spindle. This usually requires a fair amount of force. And no, I'm not going to wail away on it with a sledgehammer. I prefer a less violent method. And that means that I basically need a shop press. But such presses tend to be somewhat expensive and take up a lot of space in the shop, which can be annoying if you don't have a routine use for such a tool. I wouldn't use it very often at all, but right now I need it. So what I really need is a press that will function for me when necessary and can be stored more compactly out of the way when not in use. That is why I have decided to build my own according to my own design, and maybe you can do the same thing. The metal you see here cost me about $75. The angle iron is 2 feet long, 4 inches by 3 inches, and 3/8 inch thick. The flats are 24 by 3/16 by 4 inches. And these are 1/8 inch thick strap pieces. I originally wanted to go with channel irons, but it's not always easy to get that material in the size you want. Makeshift jack. First, drill the holes. Then bend the piece in a vise like this. Obviously, it's harder to drill the holes after you do the bending. Some of the side pieces will have to be tweaked. Once it's all assembled, it looks like this. Now, theoretically, it can be used horizontally, which I dare anyone to do with an ordinary shop press. And of course, you can use pieces like this if one wants. And for pressure, something like this, a 4-ton bottle jack, or maybe a 2-ton, which is a little lower. Maybe even a scissors jack. That's all up to you. You will also notice that I have engraved alphanumeric codes on the ends of all the pieces so that if it's ever disassembled, it can be put back the proper way. Now it's time to find out how well this is going to work. We have a steel plate, duct tape to the top to press against. Here's our piece. Now, let's put a little bit of WD-40 in here. And here you can see the configuration. So here we go. Well, that's part way. And here's an extension on some washers to go a little bit further. That seems to have done it. And there it is. Now we want to put these gears onto this shaft in this order. The problem with that is that this gear is too big to fit through the bearing openings, but the others easily can. So what I'm going to do to make things more straightforward is I'm going to remove this bearing. Now, of course, the shaft has to go through this opening. But to put the other pieces on, we can do it from this end with this bearing out. So how I'm going to do that is I'm going to press with this assembly of 2 PVC couplings for a 1 1/4 inch PVC pipe on top of a plywood disc. Now maybe aluminum would be better, but I'm going to use this for now. This needs to be 2.185 inches in diameter to just fit through the lip that the bearing seats against. By the way, I bolted the top pressure plate into place, as you can see, with 4 3/8 16 bolts. The duct tape was pretty lame. Here's the setup with some foam. And so here we go. And there it is. Okay. As one can see, the lower bearing is sealed on both the inside and the outside lower surface. The upper bearing is not. You can clearly see here the cage for the bearings exposed. And it looks like the outside is not really sealed either. I don't happen to like this, so what I'm going to do is I'm going to order another bearing set, another bearing like this one, to replace this one. And when that gets here, I'm going to proceed. All right, now, while we're waiting for the new bearing to arrive, we can assemble, in the meantime, the gears onto the spindle in the housing. Now, this big gear is the problem one that we're going to have to put on first. It's keyed, as you can see. Now, what I've done is I've put a Sharpie ink mark on this notch because it's right over where the keyway is. So you will be able to see this from the side when you're looking in to the housing. Otherwise, it may be nearly impossible to see it. What you're going to want to do while you've got this gear inside the housing is you're going to want to put it on and line it up as best you can and push it on to the spline as far as you can, which may not be very far because it's going to be very awkward to work in there with your hands. And then we will have to seat this bearing in the housing with the press and then go in and try to push from the end the gear the rest of the way up to this point. Then we can load the other gears from this end of the housing in the big hole left by the removed bearing. So I'm going to attempt that next. Okay, here we go. Wow. Okay, there's the notch where it should be, more or less. Okay, it looks like it's more or less lined up. This PVC tool from previously seems to have been quite a bit of a help. Now I'm going to try to seat this bearing. Now, what's good for this is a piece of 2-inch PVC. I've cut this from a 2-foot long piece and trimmed it in the lathe so the ends are square. But you can see that it fits it's just a hair smaller than the outside diameter of the bearing. So it should go on here very nicely in the press, and it should work. Okay, here we go. Okay, that seems to feel pretty seated. And it looks like the gear is not quite on the key. Okay. As you can see, it's a little bit too high there. Well, it seems to have gone right on because the key was a little bit rounded, and it wasn't such a stiff placement on the shaft. So it appears that we now have that gear fully installed. And now we can place some of the other gears in there from this end. Okay. Now we can put in the steel spacer and smaller gear. It slides fairly easily. And finally, the other plastic spacer. And there it is. That's all together, all the gears on the spline. The hard part is now done. So, the company that I ordered the replacement bearing from refused to send it to my mailing address. So I canceled the order and did the next logical thing. I rated my mini lathe to take its bearings, and that's a whole nother project, the mini lathe, which is going to get not only steel gears, but a set of Timken tapered bearings. Now, looking at this out of the lathe, I got both of them. It looks a lot better than this that I took out of the mill. So I'm going to use this to replace this to finish the current mill project. And I have a spare here. By the way, I made these to take the bearing closest to the chuck in the mini lathe off of the spindle. Okay, here's the setup. Just fits. So, here we go. Okay, now we can install the change gears. Now, the first time I had plastic gears, and this is what broke, not the main gears on the shaft. That's why I didn't need to have a shop press the first time, because these are easy to replace without a shop press. Now I have already put the end caps on, the end pieces on, as you can see here. You can do that at this stage. So now what we want to do is we want to put this gear in here and put this shaft through. Make sure you put it in the right way. It needs to go, as you can see, it needs to go this way. So checking again. Yes, that is the right way. I'm going to use a socket to push this bearing in. Doesn't take that much force, so we don't need a shop press to do this. Now you notice shaft is not going necessarily with the bearing, and this is going to result in a little bit of finagling. So now I'm going to put The other bearing, now notice, this is the end that takes this gear driven by the motor. It needs to be on the same side as this part of the spindle, not this part. That's where the tooling goes. We can't see the circlip groove because this shaft has come out on the other end. So now we have to finagle this. You'll have to excuse me while I do this. I have it on the edge of the table, trying to hold the other end down. Now I'm going to put the circlip on this end. Now that both circlips are in, we can proceed. Let's put in the shifting fork. We want to line up this hole with this set screw. Make sure it's that hole and not this one. And tighten down the spring over the ball. To about there. Okay. The shifting works. So now, let's put the motor-driven cog on. Make sure you have the key in. This little collar down. Now to put this collar on, and tighten down this nut. Left hand thread, don't forget. And tighten the set screw. And there it is. Ready to go. Ready to connect back on to the headstock, the rest of the headstock. Now, what you're going to want to do as you reconnect this to the rest of the headstock is you're going to want to check the alignment with the column, because there's a little bit of play. There's no locating pins. If this part of the headstock is twisted a little bit this way or tilted a little bit this way, you will not get a clean cut. So you may want to check out a web page with a piece by Earl Hackett, who shows you how to do that. And so go ahead and put it back. Well, that's it. So until next time, bye.